This is an intro to Python notebooks and Google Colaboratory. Python notebook, which is also called a Jupyter notebook, is a sequence of what are called cells or chunks containing text or code. It also shows the output from each code cell right below the cell. We'll show that in a minute. To edit a text cell, I just double click at it and it gives me the chance to edit over here, and it shows me a preview of how it will turn out over here. So I can type something here and the preview updates. To finish, there's also a nice toolbar here of various things like itemized lists and web links and stuff. To finish editing, you can either press Shift-Enter or the Escape key, and it goes back to that. This is also a text cell, but it has a hashtag before a line, and that makes it a header, and that shows up in the table of contents over here. So that's a nice way to organize things. So this is a Python code cell. You can see we're assigning the number 50 to a variable called total meal cost, and the number 4 to a variable called number of diners. But let's talk about running the code. Right now, nothing is running the code. You can see up here, there's a button that says connect or connect to a new runtime. That means I'm not connected right now. There's no runtime out there. If I click on connect, it will take a few seconds here. It shows you some progress down here. And once it finishes, it has a little graph of how much RAM you're using right now and how much disk space. And you can get more details there if you want. But now there's some computer out there in the cloud running this Python, or ready to run the Python. We haven't run anything yet. So I can click this little play button, and it will run the code, and it shows how many seconds it took, and it was 0 seconds, pretty fast. And it gives a little green check mark like this thing succeeded. Now this didn't ask for any output, so it didn't show me anything there. I can click the next cell, for example, and that also took 0 seconds. And where am I going to see the output? Well, I could use my variable inspector here, the X in the curly brackets, and that shows me my 3 variables. It shows me what type they are. Since I didn't have decimals on total meal cost or number of diners, it's just saying those are integers, that they are not allowed to have decimals. The cost per person is what's called a floating point number, which is allowed to have decimals. So that's why it's saying float there. If I hover over them, it'll show me the value, but I can also drag this bar to show more values, show more space, or I can use this little scroll bar. So that's a handy tool. The variable inspector, like it says, can slow things down, so I usually keep it closed when I don't need it. If I want to actually have it print the output here, I can add a code cell and say print cost per person. And I can, again, hit the play button, or I can hit Shift-Enter, and it will run it. And that prints what it had computed as the cost per person. You can hit Shift-Enter, and it will run it and move to the next cell if there's a code cell right under it. Or Control-Enter will just run it and not move to the next cell. Or Alt-Enter will run it and then insert a new code cell. Kind of handy. One quick thing, if you know R, you might be used to typing a little left-pointing arrow there to store numbers in, or other things into variables, but that does not work in Python. You need to use just a single equals. Other nice tools here, you can use the magnifying glass to search within the code or the text. That often works better than doing Control F in the browser for me. Don't worry about this key thing. That's for hiding things that are like passwords, which we hardly ever deal with. And then there's this file browser that shows you that there's some sample data sets ready for you to use about like California housing prices. This one is about recognizing handwritten digits. And sometimes we'll upload files from our hard drive into the file structure here and then read them, but we'll talk about that later. One thing, if you do upload files here and then shut down the session or don't do anything for a long time and it gives you an idle timeout, then you have to upload those files again. So that can be kind of a pain. I mentioned you can run each cell in sequence and it'll actually show me what number I had used when I ran this one first. So it says this is the first one you ran, this is the second one you ran. I had run this one previously, and this was the sixth one I ran. So it's possible to execute them out of sequence, which can get really, really confusing. Like sometimes you want to do that if you've done a bunch of computations and then you're just changing how the graph looks. But really what we should do in a lot of cases is just say run all, and it'll run it from the top down. And sometimes you even have some variables set in a way that's unfortunate, so you often want to just reset all your variables. So for that, you would restart session and run all. You should do that relatively often, as long as your calculations don't take too long, just to be safe and make sure that when run from the top down, it does what you're thinking. Let's play a little bit with this idea. So we've done the cost computation here. But what if we change the number of diners? Now the number of diners is 3, so if the cost was $50, but the number of diners was 3, what should the cost per person be? Well, let's run it and see what it says. It has not changed the value. That's because we have not rerun this line of code. I shouldn't really go up here and run it again. I should come back down here and run a new copy of it. Let's do that. Sorry, it's being a bit slow here. So this is quite different than what spreadsheets do. It will not automatically update values when they were computed based on other values. So that's something that you really need to keep in mind. I also want to show that Python and most programming languages are sensitive to uppercase and lowercase. So you really shouldn't have variables who are different only by uppercase, lowercase. Where this is important is if you had already typed something as %change, but then later with a lowercase p, but then later used an uppercase p, it will give you an error. So that can be frustrating. Another random thing that's perhaps surprising about Python, and that is that to do powers, you don't use a caret like you do in a lot of other languages. You use 2 stars in a row. If you do use a caret, it won't give you an error, which is kind of dangerous. It'll just give you some weird thing that you don't expect. So you got to watch out for that. Every now and then you'll need to go to the main Colab launch page. Here's what it looks like. And just to show you that there's a lot more in Colab than the boring stuff we've been doing so far, here's some graphs that we might see later in the semester. One last note, Google Colab files are kind of like Google Docs, but also kind of not like Google Docs, where multiple people can see them at the same time, but you aren't allowed to make changes from multiple computers at the same time. It can get very confused about which changes have taken effect. So if you and a partner want to work on something, you should coordinate, like, I'm going to work on it between this hour, and then you refresh your page, and then you work on it between this time and this other time. So you just have to watch out for that.